In one state, only 2 electrons can be there. So what we do, we calculate actually the number of electrons in our given volume, then how many electrons will be there. So I can write that if I consider that this sphere, which is having a radius equals to kf, the radius of kf, the f means the Fermi surface, the Fermi, from Fermi. So this sphere is all the occupied levels, and occupied levels are denoted by the Fermi surface, because Fermi surface gives us the barrier between the occupied and the non-occupied. So the surface of this is all occupied by the electrons, and this we will call the Fermi surface, and the radius of this surface in this sphere will be kf. So now if I consider the radius of this sphere is kf, and the volume of each block that I calculated is pi cube over v. So we will consider a pair of electrons, because in one state we will have 2 electrons, pair of electrons, one with spin up and the other with spin down. So I can write that what will be the volume of this, if radius is this, volume of this sphere. Volume of this sphere will be 4 by 3 pi r cube, but here r is kf, so this is kf cube. So the volume is this much. I can write the volume, and this is 4 by 3 pi kf cube. And now inside this volume I consider one block, this one block, and this one block is having 1/8 of the electron, because each block is connected on those sides, means up and below, left and right. So 1/8 times the volume will be equal to the volume of the block, which is pi over v, pi cube over v. This is the volume of the block, the very first block that I am considering here. This is the volume of that block. And how many atoms are there? N atoms are there, and each atom is giving q free electrons, and these electrons are coming in pairs, because 2 electrons per state. So now I am calculating that block, that how many electrons are there in a block. So this is equal, we assume here that there are n atoms, each atom gives q free electrons, and each block is having a pair of electrons. Each pair needs a volume this much, which is pi cube over v. So I can write, now I will have to simplify this one, and on the other side, this is the total volume, and this is the volume which each block is occupying. So I will have this thing, I will have to simplify this. So 4 and 2 here, and 2 is cancelling with this 2, and I will write that pi goes with this one and it becomes pi square. So from here, kf cube is equal to 3 times pi square, 3 times pi square, and nq over v. Now, this nq over v, the number of atoms, the number of free electrons given by them are providing, each atom is providing q free electrons per unit volume. So it means it is the density of free electrons. So I can write that this implies that Kf is equal to 3 pi square and density of the electrons, and power will come out to be 1 over 3. So this is I will call that this is the radius of the occupied, the radius of the occupied octant, 1 over 8 of K space. So this will come out to be the radius of the occupied octant, means not of the whole, because of the whole, this volume of the whole sphere is 4 by 3 pi kfq. And now I found the value of kf for the octant, means the one block that I am considering. Okay, so let me repeat this in order to understand this. We consider a sphere, and inside this, the radius of the sphere is kf, and the volume of the sphere is this much. Now, inside this sphere, we are having blocks, and each block is having an electron. So each block, out of the block, 1 over 8 of this whole volume, each block is representing for the electron. And as the electrons are coming in pairs, because each block is representing one state, and each state is occupied by 2 electrons here. So this is the number of total electrons divided by 2. So I will calculate for a block here. And here this is the space which is occupied by each electron, which is an octant, which is 1 over 8. So I have found the radius of the sphere of the in K space, or of the Fermi sphere here. So in terms of the density of electrons, so I can write that the Fermi energy means the energy of the occupied levels, the energy of the occupied system is EF, which we call is the Fermi energy. It will be h bar square kf square over 2m. And I will put the value of k from here. So this is h bar square over 2m and 3 pi square rho, and this will become 2 over 3. And now I'm having a question. And the question is that how do we find the total energy? How do we find the total energy of free electron gas? means we are to find the total energy of the free electron gas. So how we will find this one? Let's say, consider this here, that this is a shell of, means I will focus on one cube here, that the inner, this is shell, and the shell thickness is dk. dk is the shell thickness. So the inside it comes as k, and then when it goes to the outer layer, then it is k plus dk. So the thickness of this is dk. And now means this whole sphere is made of, by integrating the dk, I will get the total energy of the system this way. If I do integrate on dk, what is k or k space? Because this is the k which is going on and becomes kf is the radius of this sphere. So I can write that the volume, which is 4 by 3 pi, I can write this, the volume is this one, 4 by 3 pi, and now I am not writing kf but just k. And if I write it like this, that I want to introduce k in dk as well, so I do integrate. And when I write, this is k square dk, and when I do integrate, it will come out to be, if I remove this one, 4 pi and this. Now when I do integrate, what it will become? It will become 4 pi and then k square dk. It will become k cube over 3. So it is this one. So if I want to write it in dk and I want integration, so this will be the total volume. So the total volume is 4 pi k square dk, because in integration it will come out to be the total volume. And I am considering an octant here for the electron, 1/8. So this comes out to be simplified 4 and 8, so 2. So we are having half pi k square dk. This is the volume which is occupied by an octant or one block, and for an electron. Now the number of electron states in this shell, the number of electron states in this shell, means the shell whose thickness I have considered is dk, will be this much volume, which is half pi k square, half pi k squared, and divide by the total volume of the block, pi cube over v. This is the volume of the block which we have here. So I am just finding out, now as I know that this volume is occupied by not a single electron but 2 electrons, so I will have to multiply it by 2 as well, and then I can simplify. The 2 will cancel here and the pi will also simplify, so I can write v over pi squared k squared and dk. So this is okay, I will have to write dk here as well. So this is v pi square k square dk. Now each of these states has energy. Each of these states, okay, each of these states has energy which is equal to Ek and h bar square k square over 2m. Now I will calculate the energy. I will now calculate the energy. Therefore, the energy of dk shell, of dk thickness shell, and will be, how much will be that energy? I can write it will be a differential energy, means very small energy, because I am just considering this much shell. It will be the total energy k square over 2m multiplied with this fraction. So it is v over pi square k square dk. The shell will have that energy. Now this one, this is the energy of each state, while this one is the number of electrons, states in the shell. So the energy of each state and the number of electrons in that thickness. So I can now write that the total energy, I will now do the integration, the total energy will be equal, if I do integrate from 0 to the Fermi energy, which is this one, okay, as I am doing integration on k, so I will integrate it up to kf, means the radius of this sphere, and dE, I will integrate this one in order to get the total energy. And this was our question, that the total energy of the free electron gas. So this is equal to dE, and now I do the integration. So we will have h bar square v here and over 2m pi square. These are the constant, and then from 0 to kf, and here we are having k square here and k square here, it becomes k4 and dk. And I find this integration is equal, means this will become k5 by 5. So I can write h bar square kf, when I will put the limits, kf and 5 multiplied by v divided by, when this is k5 over 5, so 5 into 2 will become 10 and m pi square. So this is the energy, the total energy, and now I can put the value of kf. So kf is equal to this, put the value of kf, which is h bar square over 10 m pi square and put the value of kf raised to the power 5. So it is 3 pi square rho, and 1 over 3 and 5, so this is 5 over 3, and V will come here with this V. So we are having the E total equal to, now here is V and we are having V here as well, because over here we wrote this rho equal to NQ over V. Rho is NQ over V. So I will have to simplify this V with that V, and it is h bar square over 10 n pi square, and this one will become 3 pi square, and NQ I will keep here and raised to the power 5 by 3, while V will have power 5 by 3, and this is having 1. So 1 minus 5 by 3, it will come out to be V minus 2 by 3. So I calculated the total energy which is equal to this. But now, in quantum mechanics, this energy is similar to the internal thermal energy, which we denote by U of the ordinary case. So this is like the internal thermal energy of the system. So this will exert, means as it is internal energy, so this energy will exert some force on the walls of the box, and if the box expands by volume dV, then the total energy will decrease. So the total, if the volume means it will exert pressure, and let's say that dV change occurs in the volume, so it will decrease our energy. It will decrease the total energy, because when the volume expands, energy decreases. And I can write that the fraction of energy dE, I can write it like dE over dV into dV.